So we're going to skip these two labs. I think you've probably already taken a look at one of them by doing some of this homework, and also by getting on Desmos and trying to do some of those graphs. What we're going to do now is to actually analyze what does a parabola look like without having to use a table of values, without having to use Desmos. Okay, so first of all, I want you to take note of this. This is another form of a quadratic equation. Remember, we talked about what general form is. This one is what we call vertex form. Okay, this is nice, and you'll see why we call it vertex form as we go through this lesson. So the most basic parabola is y equals x squared. There's no x term, there's no constant term. This is the one we looked at, the very first example that we drew out. All right, it had these points, if you remember. And being symmetrical, it would have -2, 4 here. Okay, so that's your basic parabola. You should become pretty comfortable with that. Now what we're going to do is we're going to take that parabola and we're going to try to change it. How does it move? How does it become bigger, wider, shorter, whatever? Okay? The first effect that we're going to do is put something in for a. So if you look at that vertex form, you see that a is always in the front of the equation. So what happens if we change the value of a? For example, what happens if we say a is 3? Okay, this is x squared. Again, I'm going to put these points, I'm just going to, you already know what they are, so I'm not going to label them because it'll get a little bit messy otherwise, but how does it change if I put a 3 in front? Okay, and for today, I'm going to look at the table of values because it helps us see what's happening, but after this, you won't need the table of values. You're just going to know what a does. Okay? So I want you to think about this. If I take a 3 and multiply every one of these graphs, how does that affect my new y? Well, if I put a -2 in for x squared, it would become 4, and then multiply by 3, this is going to become 12. This would become 3. This is still going to be 0, but this is 3, and this is 12. Okay, so let's look at what it looks like on the graph. So when x is 1, we're now going to be at 3 instead. And when x is 2, all right, what's going to happen to this point? Is going to go way up here. When x is 2, y is going to be 12 now. And if we do the same thing on the other side, you're going to see this graph looks, ooh, that's not quite right. Okay, this graph's going to look something like this. So how would you describe that graph? How does it compare to the graph of x squared? Well, it looks narrower, right? But really what's happened is, if you can picture the arrows, if you can picture grabbing the arrows and pulling them up, you've stretched the graph. Okay? Now it looks narrower, but you've actually stretched it. What if I put a half in front? Well, then my y values, instead of multiplying them, I'm going to be multiplying by a half. So instead of 1, 1, I would get this point here, it would be 1 1/2. And if I get, instead of 2, 4, it would become 2, 2. Okay, and so this graph is going to end up looking kind of something like this. All right, that looks like it's wider, but really what you've done is you've squished it. You've taken those arrow heads and pushed them down. Okay? So, in general, what does the value of a do? Well, it looks like if a is bigger than 1, it makes it narrower, and if it's less than 1, it makes it wider. When you get to grade 12, we're actually going to call this a vertical stretch. Okay, and we're going to call this one a vertical compression. Now, you don't need to know that language, you just kind of have to know what is it going to do to the graph. So are you able to draw what this new graph is going to look like? Okay, now we did this example yesterday. What does the negative do in front of the x? It's just a flip. It's going to turn it upside down. We call this a reflection over the x-axis. Okay, so knowing that, we should be able to draw this graph without a table of values. Okay, let me just refresh your memory. What is this graph? Oh, that's not very nice. Let's draw it a little bit better. Here is your basic x squared graph. Now, how does the negative 5 affect this graph? Well, the negative is going to turn it upside down, and the 5 is going to stretch it or make it seem like it's narrower. So if I were to draw it, it would look something like this. Okay? So I don't have any points on there. I know we have 0, 0. What would the first point be? Give me 1 point here. If x is 1, what is y going to be? It would be negative 5. Okay? And then, of course, you would know negative 1, negative 5, and so on. So what's the vertex? 0, 0. What's the domain? Negative infinity to infinity. What's the range? Negative infinity to 0. The axis of symmetry, x equals 0. What are the zeros or x-intercepts? There is only one. It's at 0. Does this have a min or a max? It has a max. And what's the y-intercept? 0. Okay? So that's how you're going to be graphing now. You're going to be able to look at the regular graph and just know how is it, and we use the word transformed. Okay, so that's the first characteristic of change. Now let's look at what happens if we add a value after the x squared. Okay, this is what we call a vertical shift. It's going to go up if it's a positive number. It's going to go down if it's a negative number. All right? Now, again, we're not going to use this, but if this was our basic graph, and we had 4, 1, 0, 1, 4, what is adding a 2 going to do to it? The new graph, if I add 2, would have 6. If I add 2, would have 3. If I add 2, would be at 2. So this plus 2 is going to take the graph and move it up 2 units. Okay, so I want you to think about this for a second. Here is your base. Oh, having trouble drawing this. Here is your basic x squared graph. Okay, there it is. Now if I take this and move it up 2, okay, I would know the vertex is at 2. What else do I know? What has happened to these points? Well, this one would be at 1, 3 now, right? It's gone up 2. And this one would be at 2, 6. It's gone up 2. Okay, what's the vertex? 0, 2. Domain is still the same. What's the range? The range starts at 2, goes to infinity. Axis of symmetry, still x is 0. Are there any zeros now? Does it cross the x-axis? None. Okay, does it have a max or a min? It has a minimum. And what is the y-intercept? The y-intercept is 2. Okay? Let's try this next one. Again, you should always pretty soon you're not going to be drawing this, but let's always remember what does the basic graph look like. Okay, now what is this minus 3 going to do? This is going to take my graph and it's going to go down 3 units. Okay, so my vertex is going to be at negative 3. All right, and I'm going to just draw this parabola, and then let's put some values into it. Okay, do I know what this value is when x is 1? Okay, originally it was y was 1. If I go down 3, it's now going to become negative 2. Okay. Now, what about these points, the x-intercepts? We're going to have to figure that out in a second. So let's put the vertex. Vertex is 0, negative 3. Domain, negative infinity to infinity. The range, this is going to be from negative 3 to 0. And the axis of symmetry is x is 0. So far, so good. Now, this is the part that's a little bit tricky. So let's figure this out. If I want to find the zeros, the x-intercepts, that's where y is 0. So let's make my equation equal to 0. 0 is x squared minus 3. Now, can you solve this equation? Yeah, this is what you did all last unit. Okay, and do you see this one? If we bring the 3 over to the other side, and if I take the square root, I'm going to get plus or minus the root of 3. And in fact, that's what these points are. Here is root 3, and here is negative root 3. Oops, not root negative 3. So I get plus or minus root 3. Does this have a max or a min? It has a minimum. What is the y-intercept? Negative 3. All right. Another characteristic that we're going to affect is what are we going to do if there's a p-value? So inside the brackets, if we put a p-value in there. Okay. So let's take a look at this example. What does this 2, what does the 2 do to the graph? Okay, first of all, let's take a look at what is the value of p here. Can you see that p is actually negative 2? Alright, if you would put it into the equation x minus p, if you would go x minus negative 2, it would become x plus 2. Alright, so that's something to make sure you take note of. It's almost like it seems like it's opposite. So the p-value is negative 2. Alright, and what is this going to do? This is going to move the graph left. Left 2. Okay, so let's go look on this graph and say, if I move this left 2, what does this graph look like? Well, I know this is negative 2. What's the y-intercept now? Well, maybe you know what the y-intercept is because you remember, you know, this point was 1, 1, and if this point was 2, 4, and if we move it back 2 points, this point is going to be at 4 now. This one is going to be negative 1, negative 1, positive 1. Or maybe you don't know the y-intercept, you make x equals 0. And so in the equation y equals 0 plus 2, you get y equals 4. So you can always solve it if you don't know exactly what it is. Okay, vertex, negative 2, 0. The domain, negative infinity to infinity. The range from 0 to infinity. Axis of symmetry is always the x value of the vertex. What are the zeros? Well, there's only going to be 1, and this has a minimum. Okay, so now let's take a look at this one. Now you should be getting a hang of it. What is p? P is 4. This is going to move right 4 because it's positive. Okay, so if you want to put it on a graph, let's move way over here. Okay, it's going to look something like this. What is the vertex? It's going to be 4, 0. What is the domain? Negative infinity to infinity. The range is 0 to infinity. Axis of symmetry x value of the vertex. What are the zeros? Well, there's only one. Still has the minimum value. And what is the y-intercept? Well, let's make x be 0. Oops, that's -4. So this is going to be 16. Okay? So this is a part that I guess of the things we've learned today, this is the trickiest. So if p is greater than 0, it'll look like it's negative in the equation, right? So here p is 4, but it looks like it's negative. It's not. It's actually positive. Okay? Then the graph shifts right. If p is positive, then the graph shifts left. Okay, so let's see how good you have figured this out now. We're going to take a look at this equation and compare it to this formula. All right, in this case, what is a? It's 1. That tells me that the width of the graph hasn't changed from a regular graph. Okay, what is p? P is -4. This tells me we're going to move left 4. What is q? It's -4. This tells me we're going down 4. And when I'm saying this, I'm saying compared to the regular graph. Okay, so I'm going to draw the regular graph in here. You don't need to. Okay, I'm going to take that graph, I'm going to keep the same width, and I'm going to move it left 4 and down 4. Okay, so I'm going to draw this. And I'm just going to stop there for a second because I don't know where I'm crossing the x-axis. I don't know exactly where it's going to cross here. So just let me hang on there for a second. So the direction of opening, this opens up. What is the vertex? Well, what is this point? We have moved left 4 and down 4. Now, that's pretty significant. The vertex you should always be able to just read from the p and q values. Okay, that's important to know. The equation of the axis of symmetry, it's the x value of the vertex. What are the intercepts? Okay, pause for a second here. Let's find the x-intercept. So we're going to make the equation equal to 0 and solve this. Now I could FOIL this and get rid of the squared, or I could use perfect squares to solve this. That's what I'm going to do here. I'm going to take the square root, so I get plus or minus the root of 4, which is 2. And if I take away 2, I get plus or minus 2. Take away 4 is x. And so x is plus 4 take away 4 is -2. -2 take away 4 is -6. So now I can see that I'm going to go up here and I'm going to say this is -2 and this is -6. Okay. What is the y-intercept? The y-intercept x will be 0. So I'm going to put 0 plus 4 minus 4. Y is 16 minus 4, so y is 12. Okay, so I have -2, -6, and the y-intercept is 12. The domain, -infinity to infinity, and the range is from -4 to infinity. All right, now if you could do that question, you're going to have like at least 12 out of 40 marks on the test, because I'm going to have 2 questions where I ask you all this stuff, 6-mark questions. Okay, you have to graph it, give me all the characteristics. Okay? Let's try another one. Okay. Direction of opening. This is going to be up. What is the vertex? Remember, I can just read the vertex off. It's going to be 3, 1. So let's go to 3, 1, and I know what opens up, so let's just sketch it here, like so. Okay, the equation of the axis of symmetry is x equals the x value of the vertex. The intercepts. Do you see how there will be no x-intercepts? Doesn't cross the x-axis. And the y-intercept, if I make x be 0, I'm going to get, let's try it. The y-intercept of x is 0, I get y is 1/4, 0 minus 3 squared plus 1. So y is going to be 9/4 plus 1, which is going to be 13/4. The domain, -infinity to infinity, and the range is 3 to infinity. All right, so when you draw a graph like this, I'm going to have to see the vertex, I'm going to have to see all intercepts drawn. Okay? All right. I'm going to give you the homework now. Okay, because I think that's long enough for today's lesson. With these last two, I'll add a very short lesson to finish them off. Okay?